Emergent systems are bottom-up, decentralized, unpredictable, dynamic, and non-linear. Small actions can lead to large effects, illustrating the power of individual contributions to system behavior. Ants search for food and follow pheromone paths, forming efficient trails between nest and food. This biological example shows how collective intelligence emerges from simple ant behavior. In crowds, individuals try to escape danger and follow nearby people, leading to bottlenecks and panic waves. This social example demonstrates how collective panic emerges from individual fear responses. Routers forward packets independently, but when overloaded, they drop packets, causing network-wide slowdown. This network example illustrates how system failure emerges from local decisions. Emergence helps us understand unexpected system behavior, predict risks and failures, design better systems and policies, and explain collective intelligence, highlighting its significance in agent-based modeling. Emergence appears when many agents exist, interact locally, and feedback loops are present. Systems evolve over time in dynamic environments, showcasing the conditions under which emergent behavior arises. Agent-based modeling follows a systematic step-by-step process to simulate complex systems using simple agent behaviors. Unlike traditional equations, ABM models individual entities, allowing patterns to emerge naturally and observing system behavior over time. The process of agent-based modeling involves defining agents and rules, creating an environment, initializing agent states, running simulations over time, observing system-level patterns, and analyzing outcomes. Defining agents and rules means identifying who the agents are, what they can see, how they behave, and the decisions they make. For example, in a traffic system, agents are cars, and rules include maintaining a safe distance and stopping at red lights. Each agent follows simple local rules, not global plans. Creating the environment involves designing the space where agents operate, such as roads, grids, networks, and maps. In a traffic system, the environment is a road network with lanes, intersections, and signals, influencing agent behavior and movement. Initializing agent states involves setting starting positions, initial conditions, and attributes. In a traffic system, cars start at random locations with different speeds and destinations. Different initial states can produce different outcomes. Running the simulation over time means the model runs in time steps where agents sense the environment, decide actions, act, and system updates occur. For example, cars move, brake, accelerate, or stop, repeating this loop hundreds or thousands of times. Observing system-level patterns involves seeing how interactions lead to behaviors that no single agent intended or controlled. Examples include congestion, clustering, and stability or chaos. These patterns emerge naturally, not programmed directly. Analyzing outcomes means comparing scenarios, changing rules or parameters, studying system sensitivity, and drawing conclusions. For example, what happens if speed limits increase or more cars enter the road? This helps in policy design and decision-making. Agent-based modeling differs from traditional models by defining agents first, simulating behavior, observing emergent outcomes, and being easier to visualize. Traditional models write equations first, solve mathematically, predict average outcomes, and are hard to visualize. In summary, agent-based modeling involves creating agents with rules, placing them in an environment, setting starting conditions, letting them interact over time, watching patterns emerge, and analyzing results. ABM works by simulating individual behavior and letting system patterns emerge naturally over time. Today we learned what intelligent agents are, what agent-based modeling is, how simple rules create complex systems, and why emergence is important. Remember, small actions can create big system behavior. This is the power of agent-based modeling. If you found this video helpful, please like, share, and subscribe to the Edu AI Verse channel for more educational content.